Good morning, everyone. Welcome to our new section on exponents or powers. And what we're going to do in this section is we are going to be getting a series of rules with exponents that will help us simplify expressions that contain exponents in them. And before we can deal with simplification of these and these new rules, we have to remember a few different terms. So first off, if I have something like x to the second, remember that our exponent here is whatever is raised. That's our exponent. And the number that we're raising is called the base. So x here would be our base, 2 would be our exponent or our power. And don't forget that what we're really writing when we're saying x to the second is we're saying x is being multiplied by itself 2 times. And remember we did this sort of thing earlier where I might have taken y times y times y and said simplify that. Well, since it's a number multiplied by itself 3 times, we would say that number to the third would be another way of writing it. So you can go either way. You can write it out the long way, y multiplied by itself 3 times, or you can shorthand it, y to the third power. Now, this will open us up to a lot of new rules if we can just kind of keep this in mind and look at some of our older ideas. So we want to know what happens when you multiply two powers together. So let's say they have the same base. So I'm taking x to a certain number and x to a different number and multiplying them together. Well, let's try out an example of this. Let's say I had x to the fifth times, notice this is a times, x to the seventh. Well, if I were to write this out the long way, x to the fifth would end up being x times x times x times x times x, or x times itself 5 times. And I'd have the multiplication sign from above right over here. And x to the seventh would just be x times x times x times x, that's x to the fourth, to the fifth, to the sixth, to the seventh. So here I have 5 x's being multiplied by 7 x's, which means we have a total here of x to the, well, if you add this up, this would be 12. So that means x to the fifth times x to the seventh equals x to the 12th. This means we have found a bit of a shortcut. See how all I really did is I did x to the 5 plus 7, or 12. And that's going to work every time. I could do x to the second times x to the first, and I'd get x to the third. And that's just because of the nature of multiplication. Now, watch this. That means our shortcut rule is if you have multiplication between the same bases, all you have to do is add the exponents. So you're adding the exponents, not the x. The x stays the same, the exponents over here. And you have to watch out because there are two things that need to be true. You need to have the same base. So this only works if we have like an x and an x, or a 2 and a 2, or a 7 and a 7, or any variable in itself. The other thing is it has to be multiplication, so double check the sign before you try to use this rule. If you have addition here, well, I can't combine this one and this one with addition between. Only if they have multiplication can I use my shorthand for exponents. Same thing with division, that would be a whole different thing. It must be multiplication in order to work. So let's try this rule out. So in our first problem, we have 5 to the fifth times 5 to the eighth. And here, if I'm looking through whether or not I can use my multiplication rules, I know that they have the same base, because if you look at this, 5 and 5 are my bases here. So I can use my multiplication power rule since it has the same base. Oh, but I do need to check one other thing. Am I actually multiplying? Well, yep, that's a multiplication sign, so I know I can use my rule. And my rule tells me that if I'm multiplying exponents, all I need to do is add the powers, so 5 plus 8. That's going to give me 5 to the 13th. Now I can double check that this works by actually just putting these numbers into my calculator. So here I end up with 5 to the fifth times 5 to the 8th will give me an answer that's really huge. 5 to the 13th, the thing that I wrote instead, should give me the same answer, and sure enough, it does. That means that I know I did this one right. Well, let's try something that's slightly harder then. Here I have negative 2 times negative 2 to the 4th, and I'm just going to rewrite this so that it's in a way that I'm used to seeing it. Now keep in mind that if it's written this way, what we're saying is this 4 applies to the 2, but it doesn't apply to the negative because that's not in parentheses. So what we're going to do here is we're actually going to rewrite this and pull the negative out front. I have a negative 1 times negative 2 times 2 to the 4th. Negative 1 times negative 2 is just 2. And so I'm left with 2 times 2 to the 4th. Now the question is, what could that be? Well, if I want it as an exponent, I have to have an exponent or power right here. And what power is 2 being raised to? Well, 2 is only being multiplied by itself one time. In other words, it's just 2. So anytime you're missing an exponent, you can write the number 1. So 2 to the 1st times 2 to the 4th has the same base of 2 and multiplication between, so all I need to do is add my exponents to get 2 to the 1 plus 4, or 2 to the 5th. And that would be my final answer. In our next one, we don't have concrete numbers. Now we're working with only variables. But the bases are all the same, and I have multiplication between each of them. That means that I could combine it so I have the same base, x, and I'm going to add all the exponents. This is going to give me x to the 2 plus 3 plus 4, or 5 plus 4, or 9. And you can actually check if you did this one right as well. All you have to do is pick a number for x. Pick something besides 1, because 1 is going to just be pretty much 1 always. So do like 2. 2 is a good number to use. 2 to the 2nd times 2 to the 3rd times 2 to the 4th would be an example of one value for x that we could put in. So I've just put it into what was originally given to me. That gives me an answer of 512. That means that 2 to the 9th should be the same thing because we're saying that this is the same as x to the 9th. And sure enough, it is. So my expression here is the same as my simplified expression here. Okay, so let's do another one with negatives because negatives always throw us off. Now in this case, see how the parentheses are surrounding the negative? That means that the negative is also being duplicated. So here I have negative b times negative b times negative b, this third one over here. Well, you can see visibly that this is going to be negative b to the 3rd. But you could also have found this by saying, well, this b is just raised to the 1st power. And that means that I have the entire base, that same base, negative b, to the 2 plus 1, or 3. Okay, and our final one, what about y to the 5th times y to the 3rd? These parentheses might throw you off here, but since it's just saying simplify y first, you could just write y to the 5th because y is already simplified. I couldn't do that one over here with the b because unfortunately that negative is not simplified. That's something that's separate. So here I have y to the 5th times y to the 3rd. Well, I have the same base with multiplication between them. That gives me y to the 5 plus 3, or y to the 8. Our only other thing to do today is work out whether or not we can combine the following using the rule that we had above. And all we have to check is, do we have the same bases? Yes. Do we have multiplication between them? No. Since we don't have one of the two requirements, we cannot combine these. This would still be a to the 1st plus a to the 6th as our final answer. For our second one, do I have the same bases? Yes, they're both x. Do I have multiplication between my bases? Yes. So that means I can combine them using this rule, and I just need to add my exponents. So let's just figure out what exponent is missing. Well, remember, if there's no exponent written, that is to the power of 1, just like we'd normally have a coefficient of 1. So x to the 1st times x to the 2nd will give us x to the 1 plus 2, or x to the 3rd. Last but not least, can we combine these two? Well, do we have the same base? No. I don't even need to check multiplication because as long as we don't have the same base, I can't use that shortcut, which means I'd be left with x to the third times y to the second, and I can write or not that middle multiplication. So that is everything that we're going to do with powers. Check online for your assignment today with practice problems to do with these.